So this is a talk about SQL. But really, this talk is about what it takes to make complex software that requires mastery, but is fun to use and enables a flow state, kind of like playing an instrument. First, I want to talk about recording studios. So in my previous life, I was a musician, and I worked with artists big and small in recording studios all around the United States, and I loved it. Now, at the center of most modern recording studios is this piece of software called the DAW, or Digital Audio Workstation. And the job of the DAW is to orchestrate input signals from microphones and pieces of equipment to recorded digital audio tracks. It helps you play it back and also mix it to a near final product. And working in a DAW is awesome. Every interaction you have, you hear an instant preview of the results. You can solo individual tracks, you can loop little bits of audio, you can open plugins and tweak them, and you can hear the results as you're working. And this is really, really cool. It makes getting good at music production actually really fun because that feedback loop is so tight, right? It's a really magical experience if you've ever done it. So it reminds me of this quote from John Culkin: "We shape our tools, and thereafter our tools shape us." A number of years ago, I moved into the tech industry and began working on a different type of complex tool, data analysis frameworks. But I haven't forgotten that feeling of using the DAW. That instant feedback loop was just really, really magical. And I've been sort of missing it, I think, in a lot of analysis tools. So let's talk about SQL. Groovy SQL, right? Of all the ancient programming languages, SQL has had probably the most interesting history of them all. Despite nearly decades, and yes, decades, of criticism about the language, SQL has both endured and in fact thrived despite it all, right? Many of us here owe our careers to SQL. And databases have also evolved and thrived in interesting ways, scaling up to meet the modern needs of the internet, mobile phones, and now, this moment, in AI. Yet the interaction model of SQL is kind of still stuck in the 70s, right? You still type your query, you hit a run button, you wait, and then you respond to what it gives back. Now, as somebody who is used to instant feedback in work, my initial impressions of the SQL were not actually very good, right? It breaks flow. This is not fun. I don't like waiting. It's really hard to debug, right? I have one tool to do it, which is write more SQL. And it does not spark joy. So, everyone knows the experience of writing a new ad hoc query from scratch, right? Draft a query, hit the run button, get an error, fix it, syntax error, run it, hit another error, and so on and so forth until finally you wait, okay, and get a result set. And now your analytical brain turns on. You're wondering, what's going on with this column? It's a bunch of negatives and a huge number. You realize you got the order of operations wrong, so you fix that, wait, and finally get a result set. So this is the loop, right? Write, wait, debug. Now, writing and debugging is fun, right? That's using our active brains. It's kind of what we're here for. But waiting, that's not fun, right? That's a really passive activity. And every time we have to wait for a SQL query to run, we're context switching to something much more boring. And that'd be fine if we're writing and running queries just a few times a day. But if we're drafting a new query, we're doing it hundreds, maybe even thousands of times a day, right? And yes, that wait time does compound. But I think more importantly, it's exhausting, right? We did not evolve to wait for SQL queries to run, simply put. Now, a lot of database engine makers have focused on this wait part and have tried to make it as short as possible. But even a few seconds is just enough time for me to switch to Twitter, lose my train of thought. No good. OK, so that's drafting a query from scratch. Let's talk about inheriting a massive query with lots of CTEs. So imagine your colleague just left the company. You are now in charge of maintaining this SQL query. And all of a sudden, one of the columns looks totally busted. And you have to debug it. So you might try to do your job and read through every part of the query, piece by piece, until you just give up and start commenting out whole parts of the query just to isolate the CTE, right? Debugging CTEs is hard. Why? Doesn't make sense. So the popular BI tool, Hex, actually has a whole blog post about how you shouldn't write CTEs anymore. So Hex has this really cool feature where you can chain together SQL in a bunch of notebook cells, and then you can kind of edit certain parts in debug. And that's great if you use Hex, but it kind of makes me sad because there's nothing wrong with our CTEs. We love our CTEs. The problem is it's hard to debug them, harder to debug than it is to write them in the first place. So SQL's observability problems go deeper, obviously. How many times have you had this situation where you have a column, it's nothing but nulls, and then you realize that complex expression that you prototyped did not work out the way you hoped? To debug this, you have to break apart this expression piece by piece to figure out if it's your logic or the underlying data. SQL seems to be one of the popular programming languages that for some reason has almost no debugging capabilities, right? The solution always seems to be to just write more SQL. So that's it for human workflows. When you throw an AI assistant into the mix, things get even worse, right? You might prompt it in natural language to change something in your query, and then gives you a suggestion, which you can accept, then run the query, and then attempt to debug whether or not it even made sense. Same problem, right? Is it the logic or the underlying data? We're basically asking a non-deterministic output to be shoved into our extremely fragile, unobservable SQL system. So it's no wonder that people are terrified of throwing AI into SQL, right? There's something wrong with this interaction model that we can't make the best of this moment in AI with the tools that we have today. Good luck with the vibe coding. So I'm ragging on SQL, but I love it, and I think we can do better than that. So the question is how? Where do we even begin with this, right? So a number of years ago, Brett Victor gave this influential talk called Inventing on Principle. And in it, he says, creators need an immediate connection to what they create. And what I mean by that is when you're making something, if you make a change or you make a decision, you need to see the effect of that immediately. There can't be a delay, and there can't be anything hidden. And that's great, right? Like, DAWs have this down pat. And that makes sense that it does, right? Because the digital audio workstation has to model a physical system, the recording studio. Recording studios have to be near real time because music is real time, right? So here we have software that has to model a real world environment. You don't really get that with SQL, right? What are we modeling exactly? It's something that's abstract. And when software is meant for abstract purposes, it's easy to fall in the pattern that just because there's nothing to model it off after, it's okay if it's crappy, right? I don't think that's the way it should be. So, despite all of that, why hasn't anyone done this in SQL yet? So, let's talk about delay. How do we fix that problem? Well, we need to start by getting sharper about what we mean. So here's my definition. I want to get a result set per keystroke in my SQL editor. That is immediate, right? That is like the lower bound of immediate. So I think to make that sharper, what I mean is I need to get a result set in basically a handful of milliseconds. So your database engine can be incredibly fast, but this requirement already rules out a ton of systems today, right? Because if I have to send my query to US East 1, I'm going to pay a network cost, no good, breaking my latency requirement. You need a local database that's incredibly performant. It also has really expressive SQL. And so yes, this is a DuckDB talk, obviously. DuckDB, if you're not familiar with it, it's an in-process database engine that's super fast. Actually, it's just fast, right? That's the thing that people first say about it. They think it's broken because your queries run locally faster than you can even respond. Good example of this. I don't know if you can see this, but this is just a really simple query. It's running and returning results in like a handful of milliseconds. Awesome. So we know that DuckDB can do the thing, in theory, that we want it to do. But most real-world queries that we care about, they don't look like that, right? But they look like something more like that. A bunch of CTEs and joins. And DuckDB is really impressive at this too, right? But it's still a little too slow for keystroke-fast. So we have to do something even more radical. What we need to do is find a way to rewrite this query and target a much smaller data set than the one that we're actually querying right now. So it turns out DuckDB has a solution for that as well. There's this little scalar function actually tucked away in the JSON extension that lets you use DuckDB's internal parser to get an abstract syntax tree of any query. And this is super fast to generate, right? This is really cool. This means that we actually have the ability to analyze our query and then potentially rewrite it to target something much smaller. I'm a statistician by trade, so I'm always looking for ways to do more with less data. Awesome. Turns out we're going to need this anyway because DuckDB can query data sources far away. So here I'm querying an S3 bucket, probably in some data center in Amazon. And this would require basically some network, right? So now I think we now have all the pieces together. We can take our original query, we could parse it and analyze it. We can generate a local temp table with some subset of data, whether it's a limit or a sample. DuckDB is good at sampling. And then from there, we can rewrite our query in every keystroke and make it super fast. This works great if you're basically editing any part of the query other than the from clause. And even then, DuckDB is pretty fast, so you can make it work. So that's how you transform a big, complex CTE into something that feels a little bit more like this, right? OK, so that's it for delays. That kind of makes sense, right, what I just described. I'm hand-waving a lot. If you're interested in the technical details, come to my office hours. There's a lot more than meets the eye there. But Breck Victor has this other important point. There can't be anything hidden. So what does that mean for SQL? How do we add observability to the system? So my background is in data visualization. And there's this researcher that's well known in the industry by the name of Ben Schneiderman. He wrote this paper called The Eyes Have It. This is an academic paper. And the opening looks like this. He summarizes his visual information seeking mantra. And now I want us all to chant it together. I'll start, and then you'll repeat. Overview first, zoom and filter, then details on demand. OK, now you do it. Overview first, zoom and filter, then details on demand. Again, overview first, zoom and filter, then details on demand. Excellent. OK, so now you are all world-class data viz experts just because you've recited the mantra. So what does this mantra actually mean for SQL? How do we enable zooming and filtering and details on demand? Well, it turns out the most reliable proxy for a human's attention on a SQL query is probably the cursor, right? Where they move the cursor is where they're most interested. And so it turns out you can use DuckDB's parser and the AST it generates, along with a bare minimum amount of positional information about expressions and table references, pair it with the tokenizer, handwave, do a lot of work, and actually generate this, a path through the abstract syntax tree. This allows you to understand exactly where you are in the query at any time, at any level of fidelity, which means that you can take actions depending on where the user's cursor is. This is actually a big deal in a lot of ways. I'm going to show you some random demos of this idea in action. So this first, a little hard to see with the lighting, but this is semantic highlighting. I basically know exactly where I am in the query, so I can highlight any expression or table reference as my cursor moves. And as you can see, it's parsing the query every time I move it. It's extremely fast, right? And on the right side, you actually see that path through the AST. Cool stuff. This is totally a hat trick. I'm just shuffling the select list in place. Not useful at all. I don't think you'd actually want to use this. But if you notice, all this stuff above and the very little bit below the from aggregated data stays in place. We actually have complete control over the character boundaries of the entire AST. This is a little more useful. You can just pop up a menu if you're in a column expression and basically have it generate an alias for your column using an AI model. Super easy to do, but we know where we are in the query, right? So it makes it possible. Similarly, we can pop up a little menu and transform our select statement into a CTE. Same idea, right? The sky's the limit when you have this kind of parser-powered query intelligence. It really makes the process of working with SQL that much richer. Fantastic. So those are all the roadblocks to actually satisfying Breck Victor's requirements of not having a delay, not having anything hidden. So where does that leave us? So my name is Hamilton Ulmer, and I'm the UI lead at MotherDuck. And today we want to show you something we've been working on. It's a new interaction model for SQL that encourages a flow state, is easy to debug, and may require mastery, but is actually fun to use. And we're calling it Instant SQL. So I want to show you a few examples. And for that, I'd like to invite my colleague, Jacob Mattson, onto the stage to be my fingers. Okay. All right. So we are in the DuckDB UI, and I'm not actually sure what we're going to do, but I think we're going to query the New York City taxi data set, beloved from around data practitioners everywhere. And Jacob's just going to start typing some column expressions. What's going on as he's typing is exactly this loop where we parse the query, we analyze its dependency structure, we figure out what to cache to render a preview of wherever it is. We do that in the background, and then once it's cached, we rewrite the query, creating a really hot loop that's less than 50 milliseconds. So what you get out of this is actually a pretty novel interaction pattern, right? It's querying as you type, which is really, really cool. So, we already have a bunch of columns, great. So I see this fair amount divided by trip distance as cost per mile. Now, Jacob's Canadian, so I'm going to ask him to actually make a cost per kilometer column instead.
So I type.
Wonderful. Okay, so we've got two columns, cost per mile and cost per kilometer. This is excellent. So Jacob, can you click on the cost per mile column? So what just happened, actually, is he decomposed this column expression to reveal the next level of children in the expression tree. So part of how we're rewriting with Instant SQL is we're taking the query, and we're actually not just returning a result set, we're actually returning a list of expression trees. So we have full observability into all of the data, all the way through all of the expressions. This makes debugging really easy. So can we do the same with the cost per kilometer column? And then do the next one, trip distance divided by, yeah. Wonderful. Okay, so we see this trip distance column, and then we see a constant, right? Now, Jacob, can you just mess with the numbers here? So as you type, the changes to your query propagate completely through the tree, right? It's really, really cool. Essentially, we've transformed Excel SQL queries into a gigantic Excel function that outputs a list of trees. And then we're doing something in the UI to make it easy to explore. So awesome. We're on the right track, right? We now have a way to zoom and filter and get some details on demand. Good stuff. So like any good little data engineers, we're going to wrap this query in a CTE and then actually aggregate it, do something more interesting with it. So what are we going to do? I think, can we do something with cost per mile?
Yeah.
Excellent. Oh, good idea. Pickup day and cost per mile. I like that. Okay, so Jacob's going to find the average cost per mile because he's an accountant. And I'm going to ask him to actually do the median cost per mile as well because I'm a statistician. You should always use medians. And then we're going to group by all. Wonderful stuff. Okay, and this is why you use the median, right? Average cost, infinity and not a number. Those are DuckDB values. Great, so we need to fix this, right? So Jacob is going to click back into the CTE, and the result set changes. That's because we can render a preview of any CTE or select node in the query in real time. So now let's debug that. Let's start by just figuring out, do we have a divide by zero problem? Probably. Yeah, there we go. You see the trip distance column has got some zeros in it, so let's filter those out so Jacob can have his nice average. There we go, how nice. So as you can see, the changes that we just made in the CTE propagate to all of its children really, really quickly. It's a very cool way to basically debug the flow of your data. And also, obviously, his average cost is skewed, as you can see, compared to the median. It's another statistician joke. Okay. So I think at this point, maybe we'll write another CT. Yeah, another CT? OK, great. We're going to write like a classifier CTE that basically just figures out whether or not we're on a weekday or a weekend, something like that.
Yeah. Let's see. Select.
Case statements take so long to write. All right.
Oh, gosh. There we go.
Nice. Can we actually break that apart? Can you click on date type?
Yeah, right.
I think you can.
We go right here.
Yeah, there we go. OK,
Perfect.
nice.
I think we can click one more down.
Oh, very nice. Yeah. Very, very cool. OK, so now we have, can we scroll down to the final select node? Cool. OK, so we've got this pickup day. We're going to, I think we need to replace the trip metrics with date classifier and use that. Oh, we need a star there too. Excellent. Excellent, and then we have date type. Awesome, okay. All right, well, you get the idea. You can kind of keep going. We haven't hit the run query button once in prototyping this, right? We're just using a small sample of the data to actually get the modeling right. It's really, really cool. Now, at any point, you can still run your query because running queries has value, right? The problem isn't that running queries aren't useful. It's just that we have to do it too many times, and it's a real drag. So at any point, you can run the query. Did you do that? Excellent, thank you. And get an actual result set with the full data set. Now this one took 607 milliseconds, which is really fast, right? DuckDB is very fast. It's still not keystroke fast for this use case. Great.
Yeah,
so
let's go to the next one.
I think, so we're going to show you something else now. Let's query some other data sources. So that was a DuckDB table, right? And that's on my local file system. It's super fast. DuckDB is really well optimized for this sort of thing. But we want to show you that instant SQL really works for almost any data source that DuckDB can query. So we're going to query a Parquet file that's on the local file system, piece of cake. As soon as it's cached, you're basically modeling it the same way as if it were a DuckDB table. Super easy. So this isn't like the most exciting query. Let's actually do something different. So let's query Postgres, right? DuckDB can query data lakes. It can query S3 files in Parquet. It can query tons of external data sources. So I want to query Postgres. And to appease the demo gods, we've actually got Docker running on this computer. Otherwise, we'd do it live.
Full screen, right? There we go. Wait. Yeah?
Oh, yep, got to switch to instant SQL. Excellent. And that's it. This is actually querying Postgres. And this is really cool, right? As long as DuckDB can query it, you can actually explore it and model it in real time with instant SQL. So I think at this point, we're going to show you one more demo, actually. So we're going to switch to the MotherDuck UI for this one. Fantastic. So I mentioned earlier that AI assistants with SQL are terrifying, makes every data practitioner extremely stressed when an AI model hallucinates a comma in the wrong place. So now we're going to show you something kind of cool and use an AI assistant to basically prompt this with natural language. So let's take a look. We've got this complaint type column. There is a dash and a bunch of text in it, and we want to filter out everything after the dash. So so let's remove the text after the dash, and we'll trim the white space. And we'll give it a nice name. OK, let's see what it does. Cool. Notice in the results set, actually applied that suggestion in real time, right? So this is super cool. This basically means that you can figure out whether or not the suggestion that you just got is doing the thing that you care about. You can validate it yourself before you even hit apply. It's a really cool feature. Basically, every AI-powered suggestion feature is about to get really powerful and really fun with instant SQL. Cool. Thank you, Jacob.
OK. I'll let you switch back.
Sure. Fantastic. So that last demo, if you were paying attention, we were demoing that in production in MotherDuck. Now That's because today we're actually announcing that Instant SQL is available for all DuckDB UI users and anyone using MotherDuck as well. So I want to go back to this quote and how we got to this place and how we got to Instant SQL. So in the late 60s, this piece of technology called the multi-track recorder became viable for recording studios. This was like an amazing productivity enhancer in music studios, right? You could track different input signals separately and mix them differently. You could track certain musicians the next day. It was really awesome for recording sound. But artists and producers also saw the creative possibilities with this as well, right? And then began experimenting with tape machines in really new and novel ways, doing things that could not be done in a recording studio designed just to capture the live sound of a bunch of performing musicians. And all that experimentation that happened in the 70s and 80s completely changed the nature of music, right? It's easy for us to take that for granted because almost all the music we listen to now owes its creative debt to that experimentation, right? It's just part of the fabric of music. Reminds me of this quote, right? We shape our tools and thereafter our tools shape us. I think that's what that quote is about. Now, back to data analysis. I don't know what comes after something like Instant SQL, but I hope you go and try it and tell us what you think. And maybe you can also push out the boundaries. We have no idea what people are going to use it for, but we're really excited. So thank you.